Welcome to Introduction to Computer Science, Networks. This is Lecture E. The component, Introduction to Computer Science, provides a basic overview of computer architecture, data organization, representation, and structure, structure of programming languages, and networking and data communication. It also includes some basic terminology from the world of computing. The objectives for this unit on networks are to define what a communication network is, explain the purposes and benefits of a communication network, explain the Internet and World Wide Web, their histories and their structures, describe different ways of connecting to the Internet, explain basics of network addressing, IP addresses and domain names, and how they can be leased or purchased from an Internet service provider, introduce network classification by the coverage size, describe different network topologies, outline different standards and protocols that govern wired and wireless communications. Describe benefits and disadvantages of wireless communication and a typical wireless network setup. Describe network hardware. And finally, to introduce networking logical models and discuss Open Systems Interconnection, or OSI model. This lecture will explain the OSI networking model that future programmers and database experts need to understand, along with specific functionality for specific devices or software. When hardware and software are created, the engineers need to understand how the devices and software are going to be programmed. The operating system follows a logical model that facilitates communication between hardware and software. A logical model is composed of a series of logical layers that define specific functionality for a device or for a piece of software. The Open Systems Interconnections, or OSI model, defines how network hardware and software operate. The OSI model is composed of 7 logical layers. The top layer, layer 7, is the application, followed by the layers presentation, session, transport, network, data link, and physical. The physical layer is always layer 1, and the application layer is always layer 7. Each layer's communication is standardized so that adjacent layers know how to communicate with each other. In other words, layer 7 has the ability to communicate with layer 6. Likewise, layer 6 has the ability to communicate with layer 5 and layer 7. Layer 5 can communicate with layer 4 and layer 6, and so on. Therefore, device and software communication is standardized by operating system services. Remember that a service is simply a program that starts when the operating system loads. When a computer boots, the boot process loads a number of operating system services. Depending on the device and/or software, one service calls on the functionality of another service to facilitate network functionality and communication. To understand how hardware and software use operating system services, let's look at the example of creating and sending an email message. First, you open the email application. Then you start a new message. You type what you want to say, and you send the email. The email application needs operating system services to take the email from what is seen on the screen and make it into an electronic equivalent that can be sent out via the computer's network interface card, or NIC. Many operating system services work together to accomplish this task. Services operate within specific OSI logical layers. One service can operate in many layers, depending on what it is doing at any moment in time. Services call on each other as the email works its way towards the NIC via the motherboard circuitry. The NIC calls on services to encode the email for transport out of its port or over the air through an antenna. Then, when the next device, such as a switch or router or even an email server, receives the email electronically, the receiving device uses its hardware and services to process the email. The next few slides will examine each of the layers of the OSI model in a little more detail. In the OSI model, layer 7 is known as the application layer. Software installed in a device calls on the OS services to begin the network communication process by converting the software's communication into a format that can be readied for transmission. For example, clicking send in our email example starts this process. Note that the communication is data at this level. A web browser or any network-enabled program goes through the same process every time a user visits a web page. This is the same process that a smartphone uses to operate. No devices operate at layer 7 because this is where software works on behalf of hardware. Layer 7 is closest to the user, so this is where email is originated. However, if the example centered on the user's computer receiving an email, the discussion would begin at layer 1, which is where the NIC receives electronic signals. OSI Model Layer 6 is the presentation layer. No devices operate at Layer 6 because this is where software works on behalf of hardware, just like Layer 7. At Layer 6, the converted message received from Layer 7 is further transformed for electronic transmission. Layer 6 also handles file compression and encryption when needed. If a user emails a compressed file, the compression type, for example zip, is handled here. Note that the communication is still called data at this level. At OSI Model Layer 5, the session layer manages asynchronous application-to-application communication. When you send an email message, services at this layer record that an email program needs to receive this communication. Note that the communication is still called data at this level. The term asynchronous means that the sender and the receiver do not need to communicate at the same time. No devices operate at Layer 5 because, again, this is where software works on behalf of hardware, just like the application and presentation layers. Again, the communication is still called data at this level. OSI Model Layer 4 is the transport layer. As in the application, presentation, and session layers, no devices operate at Layer 4 because this is still where software works on behalf of hardware. The Transmission Control Protocol, or TCP, suite of protocols operate at this layer, as does the User Datagram Protocol, or UDP. The transport layer manages asynchronous device-to-device communication. For example, when sending an email, services here indicate where a file and the actual communication begin. When receiving an email, the services also indicate where a file ends and when the communication process should be considered complete. It also ensures that pieces of the communication are put in the right order, whether sending or receiving communication. At the transport layer, the communication is a segment encoded with information about the communication and instructions. Next is OSI Model Layer 3, known as the network layer. This layer manages asynchronous network-to-network communication. Services split the segment into manageable sizes called packets and then further encode each packet with information used by Layer 3 devices. A router is an example of a device that operates at Layer 3. Services prepare the packet for traffic by adding to each packet electronic pieces of information, including a header and footer. Information stored in the header includes the source and destination IP address. The footer contains the result of a mathematical calculation that helps devices determine damage to the packet. Services inform receiving devices about the packet's source, its destination, protocol, and more. The Internet Protocol, or IP, operates at this layer. Routers use IP addressing to route packets to their final destination. TCP does not operate at this level. It becomes operable in Layer 4, the transport layer. Finally, at the network layer of the OSI model, the communication is a packet. OSI Model Layer 2, the data link layer, determines applicable networking protocols for this packet. At the same time, Layer 2 services ready the packet for transport using whatever technology the NIC supports. Examples include Ethernet, wireless, fiber optic, or a combination of these technologies. The computer's NIC may use copper cable and expects a communication encoded according to the Ethernet standard, the IEEE 802.3 standard. Switches and NICs are examples of devices that operate at Layer 2. Therefore, Media Access Control, or MAC addressing applies, and MAC addresses are used for communications between Layer 2 devices. Note that the communication is a frame at this level. The frame includes all of the communication received from layers 7 through 3 and is encapsulated by a header and footer. At OSI Model Layer 1, known as the physical layer, the NIC takes the computer's digital electronic signal and transforms it into a signal that can be put on the NIC's media. Therefore, an email translates into electronic impulses and moves from the NIC to the wires at the end of the RJ45 connector, which is at the end of a network cable. The electronic impulses are bits, or binary digits. The bits transmit across the entire cable length to the next device, which is usually a switch or router. Hubs, NICs, cables, and antennas are examples of devices that operate at Layer 1. NICs operate in both Layers 1 and 2 of the OSI layer, but primarily at Layer 2. Finally, note that the communication at Layer 1 is a bit. At this point, the OSI model, its layers, and the functionality that occurs at each layer may seem overwhelming. Fortunately, there is a way to help memorize the layer order of the OSI model. Here's a mnemonic to help remember the 7 layers from top to bottom. All people studying this need Dr. Pepper. Or, if you prefer, from bottom to top. Programmers do not throw sausage pizza away. Take some time for review to remember each of the layers of the OSI model, and perhaps construct a one-sentence explanation about the functionality of each layer. Anyone who plans to work with routers, switches, or servers will most likely need to know more about the OSI model and its services. A deeper understanding of the OSI model is beyond the scope of this discussion. As discussed earlier, the OSI model shows that certain devices operate at specific layers. To review, at layer 3, routers and switches that function as routers. Such a switch is a layer 3 switch. Layer 2 has switches and most NIC functionality. Layer 1 has hubs, some NIC functionality, network cabling, and then wireless antennae. Why learn about the OSI model? Future programmers and database experts will need to understand how things happen electronically. In fact, concepts related to the OSI model are found throughout networking and programming. Many medical software applications send network traffic adhering to a standard known as Health Level 7, or HL7, named after the OSI model Layer 7. An example is an EKG image being transmitted from a machine to the patient's electronic health record, or EHR, encoded in accordance with HL7 rules. In this transaction, the receiving EHR database is informed of the type of image received, the patient record number, equipment identification, supervising clinician, and so on. The information is encoded in this communication according to the rules discussed in the OSI model. In addition, EHR database software contains HL7 encoding rules and is able to understand and act on the communication received from the EKG machine. Therefore, the EHR program uses operating system services just like any other network-enabled software. This concludes Lecture E of the Unit on Networks. In summary, this lecture covered the OSI networking model that future programmers and database experts will need to understand. It also discussed specific functionality for specific devices or software. That also concludes the Unit on Networks. To review, in this unit we explored the concept of a communication network, examined the history of the Internet and World Wide Web, investigated both wired and wireless network connections, identified various network topologies, and introduced the Open Systems Interconnection model.